Hey guys, welcome to my channel. So in this video we're going to look at bit manipulation. This is just going to be an introductory video, and we're going to look at the different bitwise operators and understand left shift and right shift, and also look at the different truth table of the operators that we have in our hand, and yeah, basically glance through the subjects that we have for this concept very briefly. Now, what is actually bit manipulation, right? So, if we do any process or anything that has to do with the bits, or that has to do with operating on the bits of the computer, remember that computers are fundamentally based on binary, which is ones and zeros. So whenever we're doing operations on those binary objects, we call that bit manipulation. And why do we do that? It's more optimized, and we kind of have cryptography based on it and a lot of other stuff. So it is more advantageous to us to learn bit manipulation if we're looking for some more optimization in our code and whatnot. So now let's look at the operators that we're going to be using in order to achieve bit manipulation, and those are called bitwise operators, obviously. Now there are 6 different bitwise operators, right? You must be familiar with them already. If you're not, just look at them once. There is the AND operator, which has the AND sign, the OR operator, which has the vertically pipe sign, whatever you will call it, and there is the NOT operator, the XOR operator, or the exclusive OR operator, and then you have the right shift and the left shift operators, right? So very easy to understand, and we're gonna look at the truth table next and try to figure out what they actually do. So pretty much all of them will take, apart from right shift and left shift, they're different. They kind of change the arrangement of the bits, but most of them will take in inputs and they'll give you outputs after doing some operations, right? So that's why we're gonna look at each of them individually now next. So let's go for the first bitwise operator, which is the OR operator in our case. Now, OR operator basically says that I'm going to take in 2 inputs, and by the way, in here we're going to take 1 as true and 0 as false. In computer science world, anything that is not 0 is considered true, and 0 is obviously considered false. So that is the case in here too. Now, so OR basically says, in order for me to return you a true, everything doesn't have to be true, only one item or one input has to be true, and that is enough for OR, right? So let's try to figure out what it means. Now, so we have X input and we have Y input, so we're taking 2 inputs, and then we have the Z, which is the answer in here, okay? So that is the result, that is the output. So when we have 4 cases. So when we see at the first case, which is both of them being false, 0 and 0, we get false, because remember I said like something has to be true, and only one thing, if it's true, then OR will return you a true output, right? So in the first case, nothing is true, so you'll get a false answer. Now in the second case, X is true, which is the first input, and we're not even gonna bother with the next inputs. We just need 1 to be true, and thus we get a true output in here, right? Now in the second case, X is 0, just fine. Let's see the other one. The other one is true, so remember, even though 1 is false, we don't care. We just need 1 to be true, and thus we have the result to be true. Now, in the last case, both of them are true, you can see. So, OR is very happy, and thus it will give us a true output, because it just needs 1 to be true. Again, these are very easy to understand concepts, but for those of you who do not understand or do not know this, it's kind of, informational, and I hope you guys are understanding it. Now let's go to the next operator, which is the AND operator. Now, AND says that, I'm going to be kind of speeding through these explanations because they're really easy to understand. Now, AND says that for me to give you a true output, I need every single input to be true as well. So let's see. the first case 0 and 0. So even if 1 is actually false, it will be false. No other case, right? So it's false. X is 1, y is 0. So false because y is false. X is 0, y is 1. It will also give you false because x in itself, like we don't even have to see y. We know that we get one false input and it has to be false. Now in this third case, which is and's case, both of them are true. So and is very satisfied and it says, okay, now, I'll give out the true output. So that is how you get true in case of and. Now let's go to the third operator, which is the exclusive or the XOR operator. Now, XOR operator is kind of like OR, but it's exclusive. I mean, it's literally mentioned in the name. But what it means is, it means that every single time, every single time one operand is like true, we don't care about the other, I'm gonna give you true. But in case every single component is true, I'm gonna give you false. So that's what XOR says. Or another way to look at it is, every single time the inputs differ, I'm gonna give you a true. And every single time the inputs are the same, I'm gonna give you false. So let's, in the first case we have x and y, they're both 0, so OR also gives it a 0 because there is no true in here. So and XOR also says that if something is if both of the inputs are same, I'm gonna give you a false. So there we go, we have a 0 as the answer. Now in the second case we can see that x is true and y is false, and they both are different, so that is gonna be 1 because, as I said already. Now 0 again is the same thing, so you get true because both of them differ. One is false and one is true. And the last case, both of them are true, but remember XOR only wants XOR gives you false for inputs that are the same, right? So you get false in this case. So that is XOR for you, and there are lots of kind of applications for XOR in cryptography and security and whatnot. So we'll make another series for XOR itself and doing a lot of questions regarding XOR. That'll be upcoming in the next few videos. Now let's look at the very easy NOT truth table. So NOT in itself, it kind of pointing at, I'm gonna turn something you give to me to its opposite. I'm gonna reverse it, right? So there's only one input. It takes only one input, apart instead of two, like we've seen in the previous truth tables. So it takes one input and it gives the other output, which is the reverse of it. So you give it false, it'll return you true, and if you give it true, it'll return you false. So very, very easy to understand. That was NOT for you. So let's try to go to the compiler and see how it's kind of functioning out, right? So let's try to do let's try to do an AND operation. So n equals to the AND of two of the same numbers, which is gonna be 5 and 5, and let's try to output this. Run, and we get the same number. Now we did an AND operation between two of the same number. By the way, remember this, if you do an AND operation between any two same numbers, you'll always get the same number back. This is because of this is because of binary operation, obviously, and if we want to look at it, and in this whiteboard, we can see, so let's represent 5, right, in binary operation. So this is 5. I mean binary representation, sorry. So when we do an AND operation between them, let's say AND. So what do we know by looking at the truth table? We know that 1 and 1 will give us true, right? Because both of them are true. 0 and 0, it doesn't even matter. Well, it's gonna give you 0 because 1 is 0. 1 and 1, again 1. So we get the same thing back, which is 5. So that's how it works on the bit level. So now you have kind of a representation of how those binary operation kind of works. So by the way, they'll have more zeros in the beginning of it, because integers in here are 32 bits and 64 bits, depending on what you use, but you get the point, right? That's right. So, I mean, it can also be 16 bits, but like depending on what you're using. Now, so let's look at left shift and right shift, right? By the way, before we do that, we can also try the same thing with OR, right? And let's see. You again get the same number, so maybe it's the same as AND. So I'll leave that on to you, and you can research about it and let me know in the comment section. So let's go to the left shift and the right shift, right? So what are left shift and right shift? So basically, whenever we try to shift the bits of an arrangement of bits to either the side, we're talking about shifting them, or we're talking about left shifting them or right shifting them, right? So let's try to understand in a more visual way. So let's say we have this bit composition, right? So when we left shift it, this way, sorry. When we left shift it, what we're getting is we're basically shifting this pattern that we have to once, depending on how many times you left shift it. Let's, for this example, we're left shifting it by 1. So we're shifting this pattern by 1, and we're adding 0 in the last of it, right? So you see, this is the same pattern as here, and we had 2 zeros and we're having 3 zeros now because we added a 0 at the end of it. So it just got left shifted by 1. You can left shift by any number you want, but that is how it works, right? Now let's look at right shifting. So it's basically the same, but instead of shifting the elements to the right, to the left, we're shifting it to the right in this case. So basically, this pattern will go one step to the right. So you see, and we'll add 0 in front of it instead of in the back of it, right? So in the last case, we saw that we're adding 0 in the back, so it made it 3 0, but in this case we're adding it to the front, right? So you see, there was only 1 0, now there was 2 0 because it got shifted to the right, and the pattern remains the same. 1 0 1 0 1 and 0. You see, the last 0 kind of got out of the scene, so that's how it works. So it just got deleted. So that is right shift for you. Now, one thing to remember is whenever you do a right shift, you divide the number by 2. And how many times you right shift it, you'll basically keep on dividing the number by 2. And if you do a left shift on a number, you multiply that number by 2. So let's take an example in here, right? So let's multiply it by 2, right? So we're left shifting 5 by 2. Now, not 2, let's do it by 1, and let's run it. We get 10, which is, as I said, so if you left shift a number by 1, you get the multiple of it by 2. The product of it by 2, sorry. If we do it 2 times, again, we'll get 20, because it again multiplied the answer by 2. And what if we take, let's take an even number, because that will be easier to understand. Let's left shift it, so right shift it by 1, which should give us 4 according to the slide, and it did give us 4. So that's how it works. And if we do 9, which is an odd number, it'll also give us 4, because we're talking about integers in here. It's going to round off to the nearest integer. So there is that, and that was it for today. We talked about bit manipulation and how it can work, and the operators regarding bit manipulation, bitwise operators, that is. We talked about AND, OR, XOR, not table. We looked at left shift and right shift, and we even understood how to kind of divide and multiply a number by 2 by using right shift and left shift. In the next videos, we're gonna find out how to find a set bit in a number, So a set bit is when you have 1 in the binary arrangement of the number. And yeah, we're gonna try to leverage that and understand more bit manipulation concepts and bitwise operators and how to use tricks on them, and more of more regarding the same concept, right? So yeah, I hope this video was helpful. Have a good day.